Solving a system of equations using the substitution method. When we're using the substitution method, we want to find, given our two equations, so we've got our system of equations, we want to solve for one of the variables in one of the equations. And then we're going to substitute that into the other equation, hence the name substitution. So what you want to do is you want to look at your two equations and you want to find the variable that's going to be the easiest to solve for. Now if there's a variable that has just the coefficient 1 in front of it, that would be the one I would suggest that you choose because it's going to be easier to solve for. You'll have less complications. Now let's start with example 1. I have 4x plus y equals 7. That's the first equation. Second equation is 3x minus 2y equals 4. Now what I like to do is I like to number my equations, and you'll see why in a minute. So I got equation 1, equation 2, and then I draw my little line. Now I'm going to look at both equations, and I want to see which variable seems to be the easier one to solve for. And if I look at equation 1, I see that there's a y. It just has a coefficient of 1 in front of it, so that would be the easier one to solve for. So that's the equation I'm going to focus on. So I go to equation 1, and I'm going to solve for y. So that means I'm going to bring the 4x over to the other side. So I have y equals, and now that 4x becomes a negative 4x. Remember, when we bring it to the other side, it changes its sign. But then I have that plus 7 over on the right-hand side. Now I've solved for my variable. This is where the substitution method comes in. You take the variable that you just solved for from equation 1, and you plug it into the other equation, the equation that you didn't solve for. That would be equation 2. And now you see why I number my equations so I can remember. Since I solved from equation 1, I want to plug it into equation 2. And if you had solved from equation 2, you would plug it into equation 1. So I solved from equation 1, so I'm going to start with equation 2. Now equation 2 is 3x minus 2y. But notice we just found out what y is. Y is negative 4x plus 7. So I'm going to substitute that in for y. So my y now becomes negative 4x plus 7, since that's what we said y is. And what does that equal? Well, equation 2 says that it equals 4. Once you substitute, you solve this entire equation. Well, that means I have to simplify. So I'm going to distribute my 2. So I get 3x. Now distribute that negative 2. So that's going to give me negative 2 times a negative 4. That gives me plus 8x. And then negative 2 times 7, that gives me minus 14. And I still have the 4 on the right-hand side. Combine any like terms. Well, I'm going to have 3 plus 8. That gives me 11x minus 14 equals 4. Next step to solve your equation, you want to bring the 14 over. Since it's negative, it's now going to become positive. Drop the 11x. And then 4 plus 14 is 18. Now we want to divide both sides by 11. And x equals 18 divided by 11. Now, in this case, we want to finish solving. We've only found one part of the solution. In other words, half of the solution. When we're solving for a system of equations, we actually need to find both variables because it's a point. It's the point of intersection that we're looking for. So we can't just leave our answer that x is 18 over 11. We also need to find the y because we need to know what point are these two lines crossing or intersecting at. So now I'm going to go back, and what I do is I go back to where we had solved for y in equation 1. So I go back to that one where it says y equals negative 4x plus 7, and I'll come back over here. So I start here because I already solved for y, and this is what we want to find. And I go y equals negative 4, and what is x? X is 18 divided by 11. And then the rest of the equation was plus 7. So now in this case, we want to finish this. So we're going to take negative 4 times 18, and we get negative 72 over 11 plus 7. Now, from here, you're going to want to create, I know not everybody likes working with fractions, but we've got to do them sometimes. We need to find a common denominator. Since the 7 is over 1, we could make our common denominator be 11. So 11 times 7, we get 77. Now, the next step is we add our numerators. It's a good review on fractions as well. Negative 72 plus 77 is 5 over 11. You just solved for y. Here is our solution. Our solution is a point. Now you could say x equals 18 over 11 and y equals 5 over 11. That works. But if you want to write your solution as a point, because our solution is in fact a point, this would be our solution. It would be 18 over 11 and 5 over 11. That is how we do substitution. Now, let's move on to example 2. In example 2, we've got negative x plus 3y equals 15, and then 2x plus 5y equals 14. Again, I'm going to number my equations. And looking at these two equations, the only one that looks more easy, I'm going to say, easier, I should say, to solve is equation 1, where I've got the negative x. Because again, that's a coefficient of negative 1, which we can work with. So I'm working with equation 1, and it's not always going to be equation 1 that you're going to solve for. Sometimes equation 2 will be the one you're going to choose. So I'm going to solve for negative x. That means I'm going to bring the 3y to the right-hand side, and then do plus 15. However, we haven't solved for x yet. When we're solving for a variable, it needs to be positive. So I have a negative in front of that x. We need to divide everything then by a negative 1. Every single term. Don't forget, what we do to one term, we have to do to all the terms. This way I get positive x equals 3y minus 15. Now we have solved for a variable. Remember, can't have negatives. It has to be a positive. Now, we did this from equation 1, so to do our substitution method, I'm going to plug it into equation 2. So let me start with equation 2. Equation 2 says 2x, but we just found x to be 3y minus 15. Remember, we substitute in what we solved for, x. So since x is 3y minus 15, that's what I'm going to plug in for x into equation 2. Then we write the rest of the equation. I have plus 5y equals 14. Again, from here I need to simplify, so I need to distribute that 2 so I can drop my parentheses. So that gives me 6y minus 30 plus 5y equals 14. Combine like terms. On the left-hand side, I have a 6y plus a 5y. That gives me 11y minus 30 equals 14. We're almost there. 2 more steps. Next step, we want to bring the 30 over with a negative 30. That makes it positive 30. Always change your sign. So I get 11y equals 44. Last step, divide both sides by 11, and we get y equals 4. Remember, again, we just found half of our solution. The other half is solving for that x. We found y. So again, I'm going to go back to where I solved for x. So you'll see my little arrow. I'm going to start with that equation and bring it over here. We have that x equals 3y, and we just found out that y is 4, and then minus 15. So we solve. X equals 12 minus 15, and 12 minus 15 is negative 3. So my solution to this system of equations is the point negative 3, 4. Remember, x first, then y. This is how you solve a system using the substitution method.